Hello, welcome to the channel. There's a bit of a unorthodox point of view at the moment. You are resting inside of the 6-cylinder Falcon head. As you can clearly see, these are quite interesting on their inclined angles, very similar to a Cleveland. But anyway, the point of this video we're going to show is how to install a beehive spring out of an LS into, well, practically anything, but you need to focus on some few things first. So what's our first detail that we need to consider? Well, the first one is quite silly, but well, it's quite obvious. Well, sometimes it's obvious is always something that gets missed. So excuse me while I try and set this up for you. Oh, where did that one go? Of course it is. There we go. Always funny things happen while you're filming. Crazy. Alright, anyway. Alright, I'm going to put that one there like that. Then I'm going to get this other one in here. Maybe you should have said, oh, I should have put all this together first, but that sometimes just, there we go. Right, what we're looking at here, from this point here, from under here to this point here, is our installed height. So I'm going to take a quick measurement, and when I mean by quick, it's rough, it's ready, just to give you an idea. So we're going to go, and where I'm holding my finger, it's to give the idea that I'm taking away the measurement of the keeper, so that I'm getting the top of the spring, which is about there. And now we have, now we have 0. It's been zeroed out. Now we're going to go back onto here, and we're going to go down onto here, and we're going to take a measurement. And the measurement is, as soon as I stop touching it, try and pull it up, keep it square. There we go, try again. Alright, a measurement comes in 1.773. Now, if we put our factory spring in here, you'll get your installed height, and you'll have a spring pressure for your seat pressure, and then you'll have, when the on max lift, when the cam goes down, cam does its operation, goes through the motion, runs off your rocker, pushes the spring down. That then loads up the retainer as it gets pushed down until you reach maximum lift, and then it returns it. The spring's job obviously is to return the valve to its seated position. Now if you're on 4.1, they are chronic for RPM problems. You try and rev one of these and you wind up with bent push rods. So all I can say is that, I can quickly just take this off again. This retainer is big and it's heavy. The same as the spring package that's on here is big and it's heavy. The valve is actually not that bad. It's not a very big valve. So it really shows just how far technology is going to go, because as you can see, that's the what do you call it, the seat, because you can't have a spring sitting on here, because if this wasn't here, because the spring does turn, if that wasn't there, the steel spring will just chew this out, and you'll wind up with a junk engine in a short space of time. So how do we improve RPM capacity without needing to go to big lengths of going to upgrading your push rod, having to go to a really thick wall, and this even goes for your cam as well. You don't need to upgrade that. Now the tests done on this was done on a Speedway engine, So what I'm about to show you has been tested, and we found that this then lifted the RPM capacity of this engine to around 6,000. Now I'm going to say 6,000 because 6,000 is going to be the magic number that you're actually going to run into a flow problem with the mechanical fuel pump. So when you exceed 6,000, it's going to want to starve. So you're going to have to ditch your mechanical fuel pump and go through an electronic one. Once you do that, then 7,000 RPM is very easily found with this Valvespring upgrade. So here's the bad boy there, a beehive out of an LS. This is an LS2 LS6 Valvespring factory, and I'll get to that specifications later for that one. So how are we going to put this into here when this actually has an installed height, or supposed to be an installed height, of 1.8 when we've only got 1.773? Well, as you've guessed, that retainer, as you can see here, that retainer is never going to go on there. So we need to get rid of that, and then we go to this. So this retainer is, there we go, comp cams 787, so standard 7 degree, and that's the specification of Valvespring that they orientate with this keeper, but you can use it with the beehive of an LS. So there's our top section. Goodness gracious, you can see my hand pretty big, can't you? Alright, there's the top. That's the top dealt with. Now we've got to deal with the bottom piece. And that's where this next beauty comes in. And this one is another comp cam specially. And this is no machine. Hold on. Let's get one out. Right, the beauty of this setup too, there's no machining required. So that is the specification there. 4863. 16 is obviously because there's 16 in a box. So your 4863. So this is the spring seat, 1.3 by 0.57 by 0.84. So there it is there. We put that onto there. And the reason for that is obviously so it can sit. But this diameter here is 1.7. So when we take our beehive spring here and we put that in there, see how there's very little side movement in there. It's enough for it to seat and not really do much else. So when we put that on there, we have it pretty good. And then we have that on top. Now we'll take away the B, because at the moment all we need is the retainer and this. Now the next piece, the next beautiful piece that we're going to use, comp cams 60516 valve locks, same as what you'd use, 1132, so that's the diameter of your valve, and it's a 4 groove, and it's 7. The most important of all is this is a 7 degree lock, and it's a 7 degree lock to match that edge there inside the diameter of that. So that's a 7 degree, and the keeper that will match inside of this, that's a 7 degree as well. So first time opening this. Right, now we're just going to repeat the process. Come here, valve. Ding, ding, ding. Put that on there. And then we're going to go drop these everywhere. That can go on there. Ah, true. Let's do it again. There we go. Alright. Okay, as you can already see, a significant saving in size and weight up the top here. Now, I'll get to this later, but if you really, when it comes to spring and how they work, there's a little bit more to it than just simply piling on spring pressure to control a valve. And I'll get to that, but I'll briefly touch on that this technology does not rely on just brute strength by having more spring pressure. So we're going to measure the height and we'll see how close we are now to 1.8. So repeat the process. Spring down. Start somewhere there. We're going to go 0, and then we're going to go down onto the seat. There we go, and that leaves us to 1.779. So really we didn't actually gain all that much. So can we install effectively a 1.8, this is supposedly a spring designed for 1.8 inches here, and we've only effectively got 1.78, so it's 20 thou tighter than what it should be on the seat. So when it comes down to this, all it really means is that the spring, the ultimate spring, spring crush before we wind up going into coil bind from this, is now 20 thou less than what it would have been if it was at 1.8. So this is all math. So I'm now going to move into the second part, and I'm going to now show you the spring pressures and show you what happens when we add 20 thou to the seat pressure at installed height. Alright, this may look sketchy, but it's actually, as long as you've got enough bite in here on your vise, yeah, you could actually even build something that'll actually hold this and put it over here so it can't go anywhere. But all we're doing is we're squeezing this. Now if this wasn't square and level, then yeah, and you're going to wind up putting pressure, side pressure on this, then yes, this spring is going to come at you real fast. But as you can see, it's relatively straight, but as a precaution, I do value my eyes, so I'm going to have these on. So we're going to compress this up to our seat pressure. So I'm going to try, how are we going to do this? There we go. Maybe we just see if we can put you, oh yeah, there we go. Hold on, I'll zoom in a little bit. Alright, yeah, why not? That looks good. Now, where's my, alright, hold on, I've got my measuring tool. There we go. Right, now, same again, I need to effectively, I got to zero out, and we have to go to, ooh, that was pretty close actually. So anyway, we're going to go down to, so we're closing up on 1.8, 3, 2, 1, 7, 6, 5, 4, 3, 2, 1. Come on, where are you? Alright, there we go. So 1.8, and we have a seat pressure of, what is that? So your actual mark, so it actually goes 0, then it goes 40, then it goes 50, and then each mark from then is 10 pound. Okay, so PSI. So we're at approximately 80 foot-pounds at 1.8. So we're going to go, now we're going to zero out, 0. So now every every inch, or every thousandth of an inch that I crush this will be measured, and this will be what the lift is. So we needed to add 20 thou. So we're going to go up 20 thou, which didn't take much. So that's 21. Okay, it's 21, and we gained what? I know the needle moved, but we might have got up to like 82. So we lost 20 thou total height, total spring compressibility, because we're now at 1.78, not 1.8. So all this means is that when this valve goes to coil bind, our lift of the cam has to be 20 thou less than that, otherwise we'll go into coil bind. Yeah, otherwise we'll go into coil bind. Get it right. Okay, now finding coil bind is one of those easy parts where we just basically crank on it and we watch the valve spring pressure go up. So we're at approaching 0.1 inch, 0.15, 2. So that is 1/4 of an inch of lift. 3. 3.7. That's 0.4. We're at 200 psi, are we? Yep. So it's 0.4, we're at 200 psi. A little bit more. 6, 7, 8, 9. Not gonna lie, I do get a bit nervous when you compress a spring like this. 9, 7, 8, 9, 2. So there's half an inch lift, and we're at 240 psi, and this is a stock LS Valvespring. Now here's the interesting thing, is there's plenty of stuff on the internet as to say how high you can actually go with this valve before you go into coil bind. So we set it at 1.8. that was our seat. So now I'm just going to keep going until we reach coil bind, and we're going to see what the measurement is, and we're going to find coil bind by watching that. So anyway, out of curiosity, we're at 0.53 inch. So if I squeeze this more, that needle should start shooting up because it's effectively bound, and it's not. So we've gone past that. We're now at 0.55. 0.55. That needle still hasn't moved. 0.6. 0.56. 0.566. 0.57, and it's starting to move rapidly. In fact, 0.576. Still haven't gone into coil bind, that's alright. 0.8, 0.58, 9. Well, there we go. So I'm just going to back that off. See how that. So where were we? 0.5. Have another shot at it. 2, 4, 3, 4, 5, 5.5, 5, 6. It does get, as you start squeezing it up, the pressures really start getting up there. But once you get to about 5, 7, for me, like if I was going to do this, yeah, that's coil bind really. It's, even though that's probably closer to, yeah, that's really the, how high can you reckon when you squeeze them? But Yeah, that's the coil bind. Anyway, that there's probably as far as you want to go on it, but I reckon 6.3. I wouldn't go that high myself. No way. But if you did go 6.3 and you minus 60 thou, which is about how much they reckon, the 50 thou limit is supposed to be between your stacks. So you can take that as gospel, you can take that as evidence as, oh look, you can squeeze the blue ones up to 5.7. But just remember that when you are at 5.7, you're starting to get 270 pounds over the nose, and they tap out. If you go all the way to coil bind, they get close to that, 280, and then it just starts to skyrocket. So it goes 280, 290, then you get to 300, and then you coil bind. But you don't really want to run your spring pressure that high. So anyway, that's your beehive. Factory LS beehive. Right, now we're going to do a comparison between your Summit Racing 174002, and this is again for an LS6, and this says it's supposed to have 0.550 Valvespring lift capacity. So we're now going to do that, and we're going to give a little bit of a test of its pressures, and also if we can get to our 0.55 and how much space we have between 0.55 and coil bind. Alright, there's our Valvespring. There we go. Nice and bronze coloured. A little bit of paint. Alright, let's go to work. Put it in the same way. Oops. Alright, same again. Alright. Same again, we're going to reset it at 1.8. Oh, hang on. 1.8. Oh, yeah, it should work, so it's already 1.8. So we'll tighten this up till we get to 0. Three, two, 1, 0. There we go. Oh, hang on, a little bit past. 3, 2, 1, 0. There we go. Right, so there's seat pressure at 1.8, and this spring pressure looks to be a bit higher. Remember, this was 80 pounds. This spring here looks to be closer to 86. So now we're going to add our 0.02 inches, because that's what they're going to be in the cylinder head. So what the spring is going to add, 89, 20. There we go. So that's 20 thou, and that is to 91. So this one here would have been 82 pound, 80, 81, 82. This one now is running closer to 90. So this spring here has more seat pressure. So this is actually a stiffer spring, and it'll be stiffer all the way through. Let's keep going, and we'll see how much stiffer we get. So you've got that. Hopefully my hand's out of the way so you can see it. Can you see it? My hand's in the way. Alright, as long as I keep my bloody fist out of the way, I should be able to find it. Should be able to see it. Oh yeah, just. Alright, keep going. Should have checked that earlier. Right, 1.1, 0.1, 0.2, 0.2 and a quarter. Right here, quarter. Yep. 3. 0.4. 3, we're coming up on half. 5, 6, 7, 8, 9, and that's half an inch lift. So half an inch. Wow, yep. I think before we were what, 240, and this one here is 255. So this one here has got more spring pressure. All right, so what happens when we get to our magic 0.55? Are we going to experience coil bind, or what are we doing? Alright, 5.3, 5.4, oh, 5.53, so we've just gone over. Oh, look how fast that actually goes up. So 5.42, 4.89, 5.51. So if you can see that, pretty much bang on 0.55. See how that needle shoots up real fast? That's coil bind. That's what coil bind looks like. Okay, see the handle move? Like I can move it, move it, move it, move it, and that pressure's not moving much at all, and then all of a sudden it starts shooting up real fast. So that's going into coil bind. So going by that, this literally is 551. It effectively means that this spring is running coil bind virtually within 10 thou of, sorry, I'll rephrase this. This spring's maximum lift is within 10 thou of coil bind. So if that's the case, then the factory LS one, we found that coil bind was closer to 0.63. So yeah, well, I will leave you to make the judgment. You can see the rudimentary, this is not exactly what they'd say it is accurate. This is not exactly accurate. But even then, even if you stacked up 10 thou difference in this, 10 thou difference in this, it means that this spring can still, you could still put 0.6 inches of lift on this spring, as long as you're at 1.8 on the seat. Okay, remember that. You've got to take your seat value very seriously, because your seat value is what's going to determine the ultimate lift capacity of your valve spring. And it doesn't matter if it's a beehive or a conventional spring like this, they all do the same thing. They're all going to crush, and when all of these here eventually touch, you have met coil bind. And if you're going to continually try and crush this further, you wind up wrecking things, and then people look to go, oh, it's a bad valve spring, or it was a dud push rod, or I got other little bits and pieces that weren't right. But the reality is that you didn't check what the spring height was for each individual valve, and you didn't check each valve lift point for each individual valve, because you can get what do you call it, measurement stack. So if a push rod is out by, again, 5 thou, and then you've got a rocker arm that adds another 5 thou, and you've got 10 thou. I mean, if you did that to this thing, you'll be running into coil bind and you'll be bending something. So just remember that. You've got to measure everything, and the very reason why people dummy fit things and turn the motor over multiple times to make sure that nothing touches or bends. Because if it gets hard in a certain spot, it's telling you something's touching, something is not right, and you need to investigate why not, or else your engine is going to be junk before you even start it up. So that is probably enough on this type of tech anyway. The next piece I'd like to talk about, but probably can't talk about it in this video because I've probably taken too long to go about the differences between the Summit Racing 550 and the standard blue LS spring. But yeah, if you want to, leave a comment and I'll go into the technicalities as to why these shaped springs here are an advancement over this spring over here. And I'll just have a look at the time. Actually, I'll chuck it in right now. For everyone that's actually asking, oh, what about, we've got junk lifters, or like we're doing bad lifters and you're running into flat tappet lifted failure. One of the things that people don't realize is these run, this is the old fashioned way of doing it, where you want to control the valve, you simply control it through valve spring pressure. So if you want more RPM out of this valve spring, you just make it bigger so that it becomes harder to push, harder to squeeze, which means when it releases all that energy back onto the valve, it snaps the valve back, and that's how you basically maintain RPM control. When you do that, when you add more spring pressure to this, it's not just the spring pressure that's added to the collet and all the stresses that goes through there. It actually travels back up the fulcrum, down to the pushrod, and goes back down to your the contact patch on the cam. So to put it into perspective, this is going to be really silly, but when you've got your fulcrum, I wish I had one. There's not one like right in my right handy, so I'll just have to use my hand. But when you've got a fulcrum like this, actually it should be that way, sorry, fulcrum pushing down, the ratio that the rocker ratio is also meaning that whatever your spring pressure is here, you have to times that, as that is the pressure that has to be exerted by the push rod to push this down. Okay, so if you've got 1.5 ratio rockers, you're trying to push 1.5 times your spring rate. So with this spring here, we had 90, and then you have to add in another 45, and that'll be 145 psi. That is actually required back down on the cam lobe at the start of the lobe, once it's starting to go into the ramp, before it actually starts to squash down onto the the valve. Now, what did we find? This was at 280, so we have to add another 140 psi at peak. So that's over the nose of the cam if at peak lift of this. If this was 0.55 inches of lift, so down on the lobe, it will be experiencing, what's that, 480? No, it wasn't, 280, 380. So it'll be 420 psi down on the flat tappet or your hydraulic roller. And this is only a 480. It's 200. Oh, why have I got 480 in the head? Blech. This is only a 280 psi spring. You can easily get these 350, 400. So if you did 400, if you had a 400 psi spring and you were running 0.7 inches of lift, and you had a 1.5 ratio rocker, you would have 600 psi over the nose. And if remember, this is only a 1.5 rocker. When you add more rockers, like you actually say you go from 1.5 to 1.6, so again your ratio, the pressure in which is required to squeeze the spring, goes up as well by 1.6. Cleveland, very very heavy valve train, they have 1.73, so almost 1 3/4. So for every 100 psi that you're pushing down on this, there is effectively 173 psi being pushed on the flat tappet. So remember, is that if you've got a 300 psi spring on a Cleveland, then you're going to have, what's that, 175, 350, you've got 475 psi, and that's only a 300 psi spring, and that's what they were running in the Boss 351s, I think. So it's a factory item. So just be careful as to the more pressure that you apply on this to get your valve train stability, the harder it is on your other components, namely your camshaft. So instead of chasing PSI to try and control your valve spring at high RPM, it will be best to get some technology, lose some weight in the valve train by running a beehive. There is another one which is called a conical spring. They effectively run an angle, a flat angle from this point to this point, instead of having what's described as a beehive, so that it comes up and then tapers at the very top. So yes, there's that one there. The other one too, this spring here has what's called a natural resonance, because it's all even and the weight up here, so there'll be a specific point where the impact from the cam will match the natural resonance of the spring. So what that means is that when the cam is squashed, it sends a pulse down the spring, which then turns around and then comes back up, and then you enter into what's called spring surge. It's pretty nasty stuff. So spring surge is the start of it, and once you go into stuff like that, you start losing control of the valve. When you've lost control of the valve, you have lost control of how the valve seals the combustion energy, and you're losing power. So your head flow may be capable of more, but your valve spring and your valve train may be letting it down. So that's my experience with this valve spring. Before I go, now the versatility of the LS Valvespring is quite good. So this here are the Holden heads. These were designed in the late 80s. They came out as known as the fuel injection heads. If you actually, this is a pretty cool piece of device, because to me they actually look like a cast iron version of the later LS. Very similar in design. The only difference is that they haven't got this notch. The LS's don't have a notch in here, but you know, look at the ends and how the valve train arrangement, very, very similar. But anyway, this if we put this beehive into here, it sits in the seat perfectly, so we don't actually need to run a seat. And the other one is that because this is a steel head, a steel valve, that sits in there quite nicely. Now the only difference is that this valve here runs 1.7 runs 1.7 inches of installed height. Now to run this spring, even when we put in, if we put standard collets on and we run the what was it, the 787, I think it was 787 retainer, it goes to 1.72, which isn't enough. But the beauty of this is that because the keepers are very similar to a Chevy, we run what's called a plus 50 thou, which surprisingly gets us to 1.78, which is the same as what I was talking about with the 4.16 cylinder head. Now I have actually excuse me I have built a set of these, and we did get them to run this on it, and I will end the video by showing you the dyno and a quarter-mile run of his. It wasn't his fastest, but it was probably certainly the most fun to watch. So I will leave you guys to watch that, and I will thank you for your video. Thank you for your time watching my video,